Good morning, class. Today we will be discussing parallel and perpendicular lines. What do parallel lines look like?
They never cross.
They go on forever.
They run side by side.
These are all great thoughts. Look at these examples of parallel lines. I agree that they are side by side, go on forever, and never cross. What do you think perpendicular lines look like?
They cross each other.
They make a right angle.
Good observations. You can see that all these examples of perpendicular lines do cross at right angles just like you said. I would like you to walk around the room and take a picture of an example of parallel lines and perpendicular lines. Then, use the QR code of the screen to upload the pictures to a Padlet. I will give you a few minutes.
That plus sign is an example of perpendicular lines.
The equal sign is an example of parallel lines.
You have found great examples of parallel and perpendicular lines. Are there any pictures that don't represent either parallel or perpendicular lines?
I don't think the computer is an example of either. It does not look like the angle between the screen and the keyboard is 90 degrees.
I agree with you, Justin. Good job. You will be working with your partners on a Desmos activity to help you determine more specific definitions for parallel and perpendicular lines. Open your laptops and get started.
The first screen asks us to use the sliders to adjust the slope and y-intercept of the green line so that it is parallel to the red line.
Okay, so I moved the slider for slope until the lines looked parallel. I also moved the slider for the y-intercept so the lines would be side by side.
Those lines look parallel to me. The next screen asks which sliders did we have to adjust to create a parallel line.
We moved both. We moved the slope to create the same incline and we moved the y-intercept to move the line close to the other line.
Yes, we did. Now on this next screen we have to make the lines parallel, but the green line has to go through the point. I have to move both the slope and y-intercept again to make it work.
I think the slopes are the same for parallel lines and the y-intercept can be the same or different.
I moved the slope to make the lines parallel.
Good. The lines are definitely side by side now.
I think parallel lines have the same slope.
Yes, but the y-intercepts do not have to be the same.
These are definitely not parallel right now.
Definitely not. I'm going to move the slider for slope to see what happens.
A slope of 2 looks perfect.
I agree.
We really only had to move the slope.
Yes, because the slope changes the incline but the y-intercept does not. This graph is a bit harder. I cannot make the lines parallel and make the green line go through the point by just moving the slope.
Let's try moving the y-intercept too.
That helps. I think I've almost got it.
So, it looks like the slopes have to be the same. One is -1/2 and the other is -0.5. That is the same slope.
You're right. But notice how the y-intercepts are different. Let's move on to perpendicular lines now.
Look! These lines make a right angle. And the slopes are opposite signs.
You're right. So perpendicular lines have slopes that have opposite signs.
I noticed that the slopes of perpendicular lines are different.
I agree. The y-intercepts are also different.
I get that parallel lines have the same slope and obviously perpendicular lines have different slope, but I don't get how the slopes for perpendicular lines are related.
Holy cow. I think I just discovered something. Look at this. On this first screen, the slope of the red line is 5 and the slope of the green line is -1/5. On the second screen, the slope of the red line is -3/7 and the slope of the green line is 7/3. On the third screen, the slope of the red line is 2 and the slope of the green line is -1/2. On this screen, the red line slope is 4 and the green line is -1/4.
So the slopes all have the same numbers. They are just flipped over.
Yes. And opposite signs.
You have done an excellent job exploring parallel and perpendicular lines. We are going to discuss this as a group now.
Great.
Yay!
Oh goody.
You will notice I have put screenshots of your parallel lines on the board. Tom, what did you and your partner conclude about parallel lines?
We decided that parallel lines have the same slope. But the y-intercepts can be the same or different.
Does anyone agree or disagree?
We agree that the slopes of parallel lines are the same. But we think the y-intercepts have to be different.
Can you explain why you think that, Susan?
Because if the lines had the same slope and the same y-intercept, they would be the same line instead of two separate lines that are parallel.
That is a good observation. Parallel lines must have the same slope but different y-intercepts. Okay, now we will look at perpendicular lines. Screenshots of your work with perpendicular lines are on the board. Allison, can you tell us what you discovered about perpendicular lines?
Yes. We found out that perpendicular lines have different slopes and different y-intercepts.
I agree. Kendra, I noticed that you found a more specific relationship. Can you explain what you determined?
Yes, I will write it on the board to help explain. The slopes of the first perpendicular lines were 5 and -1/5. The slopes of the next two were -3/7 and 7/3. The slopes of the last sets were 2 and -1/2. And 4 and -1/4. I started to see a pattern.
Hold on for one moment, Kendra. Does anyone else see a pattern?
Yes, I do. The perpendicular lines have the same numbers in their slopes.
They do. Kendra, can you finish your explanation?
If you look at the slopes, they are flipped. 7/3 is 3 sevens flipped over. And they are opposite in sign.
Excellent. We call these slopes opposite reciprocals. Opposite because of the signs and reciprocal means the fraction is flipped. So perpendicular lines have slopes that are opposite reciprocals. Tonight for homework you will be working with GeoGebra to write equations for parallel and perpendicular lines. You will find the link on Google Classroom. Good work today.